Before after demo, assured application performance using VeloCloud SD-WAN feature, dynamic multipath optimization, DMPO. Let's first talk about the topology and then we'll go over the scenarios and the WAN link conditions and how VeloCloud DMPO comes to play, dynamic multipath optimization. So you can see here, Edge 1, this branch site has the VeloCloud SD-WAN device. Client 1 is connected to the Edge 1, has multiple links. Branch 2 with Edge 2 is with traditional router. There is no SD-WAN device on this branch 2. So on my right, client 2 is without SD-WAN device. Client 1 is with SD-WAN device. Two scenarios will be tested out. One is for the real-time traffic and the second one is for TCP based traffic. For both the scenarios, we'll be using the brownout condition and the blackout condition. Scenario 1, UDP traffic, real-time traffic. For real-time traffic, DMPO action is per packet in sub-second fashion link steering, and for on-demand remediation, it is error correction and jitter buffering. Step 1, with no WAN impairments, you will see that the traffic is on the preferred link. With brownout or blackout conditions, you will see traffic in sub-second fashion will be steered to a different link or to that available link with on-demand remediation kicking in. Use case 1, real-time UDP based traffic. Let's run the scenario where there are no WAN impairments. Let's start the traffic. Once the traffic is started, we are going to do two checks, one from the orchestrator for the DMPO action, and from the client machine we'll use the user experience. So you can see here client 1 is behind the VeloCloud SD-WAN device, client 2 is behind a traditional router. Right now you don't see any problems on both the sides. Let's go and check the orchestrator here, live monitoring. Let's put that in the live monitoring mode, and then as per the business policy, traffic will pick the preferred link, in this case the MPLS link. Traffic will stay on the preferred link as long as SLA is met, and then steer the traffic to the other link once the preferred link cannot deliver the SLA needed by the application. So let's run that scenario. Let's introduce 2% packet loss, which is the brownout condition. Let's take the DMPO action here. In sub-second fashion, the traffic flow, application flow should switch over to the other link because the preferred link is not able to deliver the application SLA, and you can see out here. Now let's go and check the user experience. You can see here the user experience. On the right hand side you can see some distortion in the video. On the left hand side is the client machine with the VeloCloud SD-WAN device. You can see the difference in the video here. Now what we are going to do is, as the traffic is on to the link B, we are going to introduce blackout condition. We are going to bring down that link, and we'll see that in sub-second fashion the application moves over to the preferred link, but then the preferred link is having 2% packet loss, and that's where DMPO will kick in the forward error correction. Let's look into that. Let's run this simulation where there will be blackout condition on the link B where the traffic is right now flowing in. So let's run this simulation, and now let's just check the user experience from the client machine. Again, client 1 is with the VeloCloud SD-WAN device. Client 2 is with the traditional router. So let's check the orchestrator here. You can see that the traffic in sub-second fashion has moved to the preferred link, and DMPO, dynamic multipath optimization, has enabled the error correction for the duration of the disruption, whether it's a single link or multiple links. You can see here the link is down on the internet. Right now we only have a single link, and on that single link on-demand remediation has kicked in. So remember, error correction is enabled for the duration of the disruption, whether it's a single link or multiple links having issues at the same time. Now let's come and check the. Here is the user experience, client 2 with the traditional router. You can see the video is in kind of a slideshow, and on the left hand side with DMPO kicking in, forward error correction, the video is still intact. From the orchestrator, you can check the quality of experience for that video stream. You can see here now it's running on a single link where the internet link is down. You can see this area, and on the MPLS preferred link there are packet loss. So for a real-time high priority application, DMPO can enable the error correction for that duration of the disruption, whether it's a single link or multiple links. And you can see the before quality score and the after quality score with the error correction enabled in by the DMPO. You can see all the green patches out here. TCP traffic. Scenario 2. DMPO default action is bandwidth aggregation, and in case of brownout or blackout condition, it will be on-demand remediation. In on-demand remediation, it will do the negative acknowledgement. So let me explain here. For application that can benefit from more bandwidth, example file transfer, DMPO performs per packet load balancing, utilizing all the available links to deliver all packets of a single flow to the destination. Additionally, DMPO performs the resequencing at the receiving end to ensure there is no out of order packet. Now for brownout or blackout condition, DMPO protection comes to play, and it uses the negative acknowledgement. Let me explain that. TCP applications such as file transfer benefits from negative acknowledgement. So upon detecting missing packets, the receiving DMPO endpoints informs sending DMPO endpoint to retransmit the missing packet. Doing so protects the end application from detecting any packet loss, and as a result maximizes the TCP window and delivers TCP high throughput during a lossy condition. So for this, what we are going to do for the demo is, step 1 would be, with no WAN impairments, we'll see that the bandwidth aggregation takes place from the DMPO side, and then when we move to step 2 and when we introduce 2% packet loss on link A, bandwidth aggregation will continue, but at the same time DMPO will kick in on demand remediation. And then step 3, when we try out the blackout condition on link B, at the same time link A is still having 2% packet loss, you will see both bandwidth aggregation and on demand remediation. Here is the business policy. TCP application traffic will be simulated using iPerf application. Destination is on port 5001, protocol TCP. Networking services multipath, and links is auto. We are putting that in auto mode. For scenario 2, we are going to start the iPerf traffic that will simulate the TCP application. The server address is here, 97.20. We'll run it for 600 seconds, and here is what we are going to see the user experience. Again, client 2 is without any SD-WAN device. Client 1 is with VeloCloud SD. Let's run the iPerf traffic on both the clients, and let's see what information we see out here. And you can see when there is no WAN impairment, you can see the throughput out here. Let's go to the orchestrator, live monitoring, show TCP. So DMPO will kick in, and we'll see that both the links are being utilized with the link aggregation. You can see that the traffic, TCP traffic, is seen on both the links, link A and link B. Now let's introduce the brownout condition by introducing the packet loss, 2% packet loss on link A. And now let's see client 1 and client 2. You can see here on client 2 how the variation of the throughput is on the client, and the variation is maintained out here. Let's check the orchestrator, and you can see here still it's using the link aggregation, but at the same time now on-demand remediation has kicked in with the negative acknowledgement for TCP based application. You don't see the throughput going down. This is what is seen from the orchestrator. Now let's run the third scenario where we'll bring down link B, and there will be only a single link with brownout condition, which is 2% packet loss. Let's run that and we'll see client 1 versus client 2 here. So client 1, remember, is with VeloCloud SD-WAN device, and client 2 is with a traditional router. You can see how the user experience is going to be for the file transfer application, and this is for the SD-WAN device. Let's check on the orchestrator here. So you can see here one of the link is down. Now we have a single link, and TCP flow is shown onto that link A with 2% packet loss, which means there is on-demand remediation going on. The throughput has not decreased out here. Here at the QoE screen, you can see that there is a blackout condition on the internet link, and at the same time on link A, which is the MPLS link, you can see there is a 2% packet loss, which is the brownout condition, and you can see the before and after scorecard.